All right, welcome to the explainer. Sometimes you look at a table of numbers, and it just seems, well, like a bunch of numbers. But today, we're going to take a table just like that and uncover a hidden pattern inside. And this pattern, it's so perfect, it almost feels like it was designed. Let's dig in. Okay, here's how we're going to tackle this. First, we've got to understand what kind of data we're even looking at. Then we'll find its center point, its heart. After that, we'll see how spread out everything is. And finally, that's when we get the big reveal, the surprising story this data has been waiting to tell us.
All right, first things first. What in the world do we mean when we say grouped data? And why does it need its own special set of tools? I mean, isn't data just data?
So take a look at this. On the left, that's ungrouped data. You see every single score. It's all there. But on the right, that's our grouped data. We've kind of bundled everything into these neat little packages. Now, we've lost some of the nitty-gritty detail for sure, but what we've gained is a much cleaner, simpler picture. That's the trade-off, and it's exactly why we need a whole different approach to figure out what's going on.
And to make this super concrete, this is the dataset we're going to be working with for this entire explainer. We're looking at the hemoglobin levels of 20 students, all nicely organized into these 5 groups. This is our patient, so to speak.
All right, time to roll up our sleeves. First thing we're going to do is find the center of gravity for this data. And we're not just going to use one method. We're going to use the big 3: mean, median, and mode. So we're going to kick things off with the mean, which is really just a fancy word for the average. Now, I know what you're thinking. That formula looks a little scary, right? But don't worry. All it's really doing is helping us find a weighted average that works for our groups. It's not as bad as it looks, I promise. Let's walk through it together.
Okay, so here's our first little puzzle. Since we don't have the exact numbers for each of the 20 students, we need a single number to represent each group. And the fairest way to do that? Just take the midpoint. So for that first group, 7 to 9, the middle's 8. For 9 to 11, it's 10. You get the idea. Let's go ahead and add that as a new column in our table. Next up, we need to give each of those midpoints the right amount of, well, weight. I mean, the group with 8 students should count for more than the group with 2, right? So we just multiply the frequency, that's the F, by the midpoint, our xi. For that top row, you've got 2 students times a midpoint of 8. That gives us 16. We're just going to do that all the way down the table.
All right, now for the magic. We're just going to add things up. First, we sum that frequency column. That gives us our n, the total number of students, which we already knew was 20. But now, the important part. We sum up that new f times xi column, and that gives us a grand total of 240. And just like that, we can solve for the mean. We just plug our numbers into that formula from before, 240 divided by 20, and bam, the mean hemoglobin level for this group is exactly 12.
Okay, 1 down, 2 to go. Let's move on to the median. This is the value that's smack dab in the middle of our entire dataset. Now, yeah, that formula looks even crazier than the last one, I get it, but really it's just a precise way of figuring out where that middle value falls. It's just a sequence of simple steps.
So before we can even use that formula, we have to figure out which of our 5 groups actually contains that middle student. We call this the median class. It's a simple 3-step hunt. First, we figure out which student is the middle one. Then we make a running total of the students. And finally, we spot the group where our target student is hiding. Okay, let's actually do it. We've got 20 students, right? So the middle point, n divided by 2, is 10. We're looking for the 10th student in line, so let's check our cumulative frequency column. The first group only has students 1 and 2, not him. The second group adds another 4, so that takes us up to student number 6. Still not there. But look at the third group. It adds 8 more students, taking our running total all the way to 14. Gotcha! Our 10th student has to be in that group. That makes the 11 to 13 range our official median class.
Okay, so we're not going to get bogged down in every single calculation here. But what that big formula does is pinpoint exactly where our middle value is inside that 11 to 13 range. And when you run the numbers, what do you get? The median is also exactly 12. Very interesting.
All right, and now for the final one, and honestly, it's the easiest of the 3, the mode. This is just the group that shows up more than any other. So how do we find it? Easy. We just scan down that frequency column and look for the biggest number. And there it is, 8. It's not even close. So the most common group, our modal class, is that 11 to 13 range again.
Now, there is a specific formula for this too, but for this particular data set, it works out to be, you guessed it, 12. Okay, are you seeing what I'm seeing? Something's going on here.
So we've totally nailed down the center of our data, but that's only half the picture, right? The other half is how spread out is it? Are all the numbers huddled tightly around the center, or are they scattered all over the map? And the absolute best tool for measuring that spread is the standard deviation. It boils everything down to a single number that tells us, on average, how far any given point is from the mean. And yep, it's another one of those big formulas. But just like before, we're going to take it one piece at a time.
So, to crack this, we build out our table even more. For each and every row, we figure out how far its midpoint is from our mean of 12. Then we square that number. That just gets rid of any pesky negatives. And finally, we multiply it by the frequency to give it the proper weight. When we add up that final column, we get our big total, 96.
Okay, this is the home stretch for this calculation. We take that total, 96, divided by our 20 students, and then we take the square root of that whole thing. And that gives us our standard deviation, roughly 2.19. And you know what? That leads us straight into variance, which is actually super easy. It's just another way to look at the spread, and it's literally just the standard deviation squared.
So yeah, we can just square the 2.19 we just found, or if we want to be clever about it, we can just look at the number we had in the last step before we took the square root. See? It was 4.8. Either way, our variance is 4.8.
Whew. Okay, we have done a lot of math. But listen, numbers are totally useless unless they tell us a story. So what's the big secret here? What has all this work actually revealed about these students' hemoglobin levels?
Let's just take a step back and look at our three main results for the center point. The mean, 12. The median, 12. The mode, also 12.
I mean, come on, is that just some kind of freak coincidence? What are the chances that the average value, the dead center value, and the most popular group would all land on the exact same number? No, it is absolutely not a coincidence. This is the classic signature, the telltale sign of a perfectly symmetrical data set. What we're looking at here is a normal distribution. You've probably heard of it as the bell curve. Our data is in perfect, beautiful balance. And that is the real magic of doing this kind of work. It's not just about crunching numbers in a calculator. It's about being a detective, finding the hidden story that's locked away inside the data. So the big takeaway here isn't a formula. It's a question for you. What amazing stories are just waiting to be discovered in your own data?